We've seen how to solve a polynomial equation that is presented to us in factored form. The next most basic form in which we can encounter a polynomial equation is what's called standard form. A polynomial equation is said to be in standard form if on one side it has an unfactored polynomial, so a polynomial that's fully multiplied out, and on the other side it has 0. If we want to solve an equation that's presented to us in standard form, first we have to factor the polynomial, then we have an equation in factored form. The product is 0, so one of the factors must be 0. Okay, so how will we factor this polynomial? Well, we'll start with the greatest common factor. And looking at these numbers, I see the numeric greatest common factor is 2. And then I see that I have a factor of x squared. So I'm going to factor out a 2x squared. And then in the first term, I'll have 3x squared left. In the second term, I'll have 7x left. And in the last term, I'll have just the number negative 20 left. Okay, so now my polynomial, I have a greatest common factor times a quadratic trinomial. That's going to be a job for the AC method. So I've got my 3x squared plus 7x minus 20. AC is negative 60. B is 7. Listing through factors of negative 60, we may find a calculator helpful for this. We see that 12 times negative 5 is negative 60. 12 plus negative 5 is 7. So that's how we're going to split up our middle term. We'll have 3x squared and negative 20. We'll split up our middle term as 12x minus 5x. In our first row, our greatest common factor is a 3x. 3x times x is 3x squared. 3x times 4 is 12x. X times negative 5 is negative 5x. And then negative 5 times 4 is positive 20. So we'll have 2x squared times 3x minus 5 times x plus 4. These two are linear, so they are prime. And of course, monomials are fully factored as they come. So monomials we don't need to worry about. We've now fully factored our polynomial, 2x squared, 3x minus 5, x plus 4, and that product equals 0. The product is 0, so one of the numbers we're multiplying has to be 0. So here, 2x squared, that's a 2, an x, and another x. And then we have a 3x minus 5 and an x plus 4. Now 2 equals 0, well, those are different numbers. They can't be equal. That can't happen. X equals 0, that can happen. X equals 0 is a solution to our equation. Here we get x equals 0 again. We only need it once, so x equals 0 is still a solution. 3x minus 5 equals 0. That means 3x is 5, x is 5/3. X plus 4 equals 0. Subtract 4, we have x is negative 4. So the solutions to our equation are x equals 0 shows up twice. X is 5/3, and x is negative 4. So each of those numbers should be a solution to our original equation that we were given. So when x equals 0, our original equation, we have 6 times 0 to the 4th plus 14 times 0 to the 3rd minus 40 times 0 squared. And each of those terms is going to work out to 0. So we'll have 0 plus 0 minus 0 equals 0, as we hoped. When x equals 5/3, we have 6 times 5/3 to the 4th power plus 14 times 5/3 to the 3rd power minus 40 times 5/3 to the 2nd power. Now working this out is definitely a job for a calculator. I'm going to work out each term just so we can see what's happening, but it's totally fine if you would rather just throw the whole thing into your calculator. So our first term is going to work out to 1,250 over 27. Our second term is going to work out to 1,750 over 27. And then our last term is going to work out to a negative, of course, negative 1,000 over 9. Adding these together, we've got 3,000 over 27 minus 1,000 over 9. Cancel a common factor of 3 here. And that really is 0. It is also totally acceptable if you just want to throw this whole expression into your calculator at once and see that your calculator just spits out 0 for that. Finally, when x is negative 4, we'll have 6 times negative 4 to the 4th plus 14 times negative 4 to the 3rd minus 40 times negative 4 squared. And again, this is a job for a calculator. So our first term, we get 1536. Our second term is going to work out to be negative. So we'll have minus 896, and then minus 40 times negative 4 squared, so minus 640. And working out that arithmetic again, we really do get 0. So plugging each of these numbers into our original equation that we started with really does make the equation true. Each of these numbers really is a solution to our equation.